Hello, and thank you for attending today's webinar on Life Safety Dampers Part 1, presented by Ruskin product experts Kent Mowney and Spencer Brinkmeyer. The webinar today will be approximately 35 minutes long, followed by a Q&A session. If you have any questions during the webinar, please use the box with the question mark in the upper right corner of your screen to submit them. All questions will remain anonymous and will only be seen by the presenter. If we do not get to all questions, we will send out the answers after this presentation. At the conclusion of today's webinar, you will receive a certificate of attendance, a link to the recording of this presentation, and a registration link to next week's webinar on Life Safety Damper Installations Part 2 with Ruskin experts Mike Piazzo and Spencer Brinkmeyer. Thank you again for attending, and I will now turn it over to Spencer.
Thank you, Emma, and thank you all for joining on this latest installment of the Ruskin webinar series. We are fortunate enough today to have Kent Mowney be our primary speaker this afternoon. Kent has over 30 years experience with Ruskin, and the majority of that time has been working with life safety dampers as the life safety damper product manager. I'll be monitoring your guys' questions this afternoon, and if I can squeeze in a question mid-presentation for Kent, I will certainly do so. Otherwise, any questions I do not get to, Tessa is going to follow up with after the presentation. So without further ado, Kent, why don't you take it away?
Good afternoon, everyone. I'm Kent Mowney, the Life Safety Product Manager. I've been responsible for years to work with the building codes, R&D, designing and testing the products, and working with the building codes to make sure that the future codes, we have products ready for release when the codes change. So starting out here on our agenda is why life safety dampers, different installations and everything that comes down. So it's going to be a good preso, and if you have questions, please send them in and we'll get to each one as we come along here. First is why life safety dampers. Life safety dampers is to help people evacuate a building during a fire event, and also to try to keep, especially the corridors and everything, smoke-free, so that way when the fire department shows up, they have a better visibility to get in and put out the fire and for everyone's safety. So it's very important. I break down fire protection into 3 different groups. One is notification. Notification is like your smoke detectors, your pull stations, your heat sensors, and everything that goes into the fire alarm panel. So that way, if something happens, it's automatically goes to the fire alarm panels, and it can sound alarms as necessary for that application. Next, you have sprinklers. Sprinklers are very great. They are designed and work great on suppressing fires. In some cases, they could put out fires, but in most cases, they will help suppress a fire and try to keep it smaller until the fire department gets there and actually put them out. Then we have passive fire protection. Passive fire protection is like your drywall material, your fire stopping sealants that you put around pipes and everything that goes through the walls. Concrete, a fire protection material. And then dampers actually fall into that passive protection. So next is, per NFPA, smoke can actually travel up to 420 feet per minute. I mean, that is traveling really fast. The smoke is really what harms people. And so having dampers to help prevent smoke from migrating, or be able to open up the exhaust smoke out is a very important part of the fire protection rating in a facility. When it comes down to people getting hurt and stuff, most of it is all not from the fire. It is mainly from smoke. 80% get, they can't breathe, you can't see, you don't know where to go. And it's most of the time, it's not even in the area where the fire is at. Smoke can travel really fast and get into multiple floors within minutes of a fire starting. Now, the different threats comes down is, you have breathing problems and everything, and it's hard for the firefighter to see. There's a lot of problems that you come when you have the smoke. It's a very important thing to keep the dampers in maintenance, and so it helps prevent the smoke from migrating. Also, smoke can get up to very, very high temperatures as they travel. That's one reason they travel fast, is it can all get up to over 2,300 degrees Fahrenheit, especially in high-rise buildings. Compartmentalization is very critical. So when you design a building, you end up making different compartments, so that way you have fire areas and smoke compartments that can help trap the smoke in those areas and be exhausted out, and keep other compartments free for area of refuge or means of egress out of the building. So this all comes down into this compartmentalization. Is you have firewalls, fire barriers, partitions, smoke barriers and partitions that are all designed to help compartmentalize a building's interior to keep smoke and flame from passing from one compartment to another. You have two different types of systems. You have your active fire protection. Active fire protection could be like sprinklers, or it could be your exhaust fans and everything that actually tries to move the air out. So you have the active systems proved to be very useful for the computer system and the program in the building. What opens, what closes, what happens in each event if smoke or fire is detected in areas. Then after that, you have passive fire protection. Passive fire protection strengthens the active fire protection system. So you have to have passive protections in the walls and in the floor ceiling, roof ceiling, and all those assemblies to help prevent the passage of flame and or smoke into other compartments. So the dampers fall into the passive protection because they're part of the firewall or smoke wall assembly to prevent the leakage or the flame passing through to the other compartments.
Hey, Kent, we got a question here. I think it's pretty relatable to that subject. So someone asked, who or what dictates whether active or passive fire protection is required?
In the International Building Codes, it tells you basically if you need sprinklers or non-sprinklers and what protection it needs for different occupancies. So, and also it comes down, if you have a high-rise building, you automatically end up having to have a smoky back system, which then makes more, you have active systems and through that, and then all others, you have a passive system to keep flame and smoke from migrating. So moving into the building codes, and all that is listed here tells you what section of the building code is for your fire protection. So if you have firewalls, if a fire damper is required, if you have smoke barriers, if a smoke damper is required, and so forth. It comes down to, what section and what damper is required for that operation. This is just a quick reference of for different walls. And if you have different occupancies, some of these change for different occupancies also. Next is a little detail of where the dampers are actually located. So if we start in the bottom center here, is smoke dampers are usually the right off of a fan, or it could be in a shaft also. Fire dampers may be used on an exterior wall where the property line or building so close where you have, or another building where you have to separate it with fire protection. You have fire smoke dampers and stuff in your shafts to prevent, smoke or anything from one floor going to another floor. Depending on your occupancies, you may require ceiling radiation dampers in your fire-rated ceiling assemblies. And come back to where fire smoke dampers on your exhaust shaft as we move down. And then at the bottom of the shaft, there is, we have like I-503 assembly, which is non-concrete mounting, where you can mount a horizontal fire or fire smoke damper without having to extend the shaft walls to the floor. So this quick little reference detail just kind of show you where dampers could be located in a facility. Next is moving to the plans and specs. This is a just quick overview of what's kind of new in some of the plans and specs. Starts out in NFPA 98 in 2015. It was updated to state that the locations of the dampers to be shown on the drawings of the air duct system. So that way you don't have people guessing that if a ductwork is passing through a wall, do I have to protect it or not? So that is very important to be shown for all the engineers. Next, a new statement was put in also in that section. It says it shall have calculated airflow at the locations shown on the duct systems. This is very important because as we go through and talk about the UL testing and the testing requirements and the listing of the dampers, that having the calculated airflow at that location will then make sure that the proper damper that can operate under that flow and that steady pressure is utilized in that area. Next is something that is also new. For years, this has been a large argument through the International Building Codes and through NFPA, is what size of access door should be used in the ductwork next to the fire dampers. We come up with is that the damper or the duct door or the damper should not be less than 12 inches square. And if you have smaller ducts, that you provide a removable duct section so you can access that damper and do the proper maintenance and testing that is required. So most all ductworks, all the breakaway connections and everything are pretty much can be removed. It's just something to keep in mind. So when you're designing to try to eliminate piping, electrical conduit and everything from that area around the damper so you can access the damper. Next, we're going to get to the UL testing. Testing, all manufacturers have to test, and how they're tested is Fire dampers are tested for UL 555 test standard. Smoke dampers is 555S for smoke or leakage. Combination fire smoke dampers, you combine the fire damper and the smoke damper testing and to get both ratings. When it comes to ceiling dampers, it is UL 555C for ceiling damper testing. It's a whole different standard, and dampers are used in ceiling dampers are used in a completely different way than a fire or fire smoke damper is. Then you have corridor dampers, which are also tested to UL 555 and 555S. So through the testing, it comes down to you have your fire endurance test, which I will walk you through a video on it. You have a hose stream test, which is also in the video. And then you have an operational reliability testing that has to be done. So if you have just a fire damper, it has to cycle a minimum of 250 cycles without any apparent problems or issues. Then if it is a dynamic damper, then you have a dynamic closure testing that has to be done under flow, and I will have a video showing you that test. So let's go to you might have to click on it. Okay. The fire test here, this is a 90 by 48 FSD 36SS that we were testing. The damper is tested with our jack shaft on the top side out of the fire and down below inside the fire. This one here has two sections connected together with a pneumatic actuator on the right side. Then the left section that is opening has an electric actuator and an electric heat sensor down inside the fire chamber. So everything is set and the fire is lit. So with the left hand side has the electric actuator and the EFL link mounted in the fire. This of course is going to heat up quicker and close a lot faster. And this is how a electric actuator actually closes the damper. We call this controlled closure. So there is no quick slamming of the damper, so you don't get high pressures and explode or implode your ductwork. The other two sections were held open with a pneumatic fuse link, which is mounted up out of the fire in the very bottom corner, so the least place that it doesn't heat up as quick, but it still closes well within time. Within an hour and a half of the test, the damper reached up to almost 1900 degrees at the damper. That is very hot, and as you've seen, there was no flame or anything passing through the blades of the damper. Next, the damper is then put into position, same position that it was fire tested in, and a fire hose is pressure is calculated, set, and everything. And then the damper is sprayed down with the fire hose. This is one of the hardest part of the test because the damper is still so hot and it's still almost pliable. And you hit it with that hose pressure, it actually could bend a blade and actually cool it down into that position, and it can create large gaps. As if you've seen into the video, at one point the rest of the electric actuator actually fell off of the damper. That is fine as long as the damper stays in the closed position without any gaps or enveloping through it. So after the hose stream, the damper then is lowered down and inspected, and all gaps and everything are measured. So through this was a pass test, and as you can see, everything was closed, nothing opened up, everything. So that is a typical fire test at UL. Next, we're going to go to the heated air testing. With this assembly, is done in our R&D lab. We have the tunnel and a big 6-inch gas line feeding it. The damper is actually with air flowing through it and the pressure going through it without any heat. The damper has to cycle 3 times, making sure everything closes. We use little blocks we pull out, so we don't spend $50 for each unit for every time we cycle it. So after it is closed 3 times, the fuse link is put onto the unit. This test, the damper assembly is actually 90 inches wide by 64 inches tall. The velocity is over 3,000 feet per minute and over 6 inches of static pressure. So the burner's lit, the fan's turned on, and this is how a fire damper will actually close. Not this exact same sequence, it changes every time. As each fuse link heats up, that section closes. The air velocity through the last section that was closed was over 9,200 feet per minute, and the static pressure spiked over 12 inches of static pressure. This was a pass test, everything closed. You actually do this closure test with airflow both directions, so the damper can be installed in your system and it does not matter your airflow. One of the next tests, it's kind of one of the funner ones we do. It is called a duct impact testing. The damper is installed in a wall frame. This here is a metal stud wall, drywall both sides, and ductwork is connected to it. And the duct is kind of, suspended and kind of hung in place. Then we take 500 pounds of weight and suspend it above the damper. You drop it, and the duct has to break away, and with that, the damper must stay in the plane of the wall without any gaps or anything around it, and be functional at the same time. So this is a past test. This testing we did with all the different flange breakaway connections, so we can mix and match.
Hey, Kent, I have another question for you here. This one's more regarding installation, but since we're talking about pass-fail test, thought it was pretty relatable as well. The question is the damper fail position set in the field or in the factory?
The fail position is, the fail position of a damper is put on the order as when the dampers are ordered. And the motors and the fail position has to be set at the factory for that operation. It cannot be adjusted in the field for a different operation without recertifying the damper. So it gets very expensive if you order it incorrectly. Hope that answers the question. Okay, next is fire, smokes, and combination fire smoke damper ratings. So first, let's go with the fire damper rating. You've seen the video on the testing, and most of all dampers, over 95% of them nowadays, is an hour and a half dampers, and they have an hour and a half ratings. You used to have more 3-hour dampers and 4-hour walls, but with the more use of sprinkler systems, that most of those hourly ratings have been reduced under 3 hours, so there's not as many of them. For in the IBC and NFPA, it states that any assembly with less than 3 hours to use an 1.5 hour fire damper. And any assembly that is 3 hours or greater than to use a 3-hour damper. So this is a typically asked question. Almost every week we get this question here at Ruskin. So this is where the information is called out, and this is where we refer to it and give your answer from. Next is dynamic or static. Static systems are for when HVAC system shuts down during a fire alarm. A dynamic damper, the HVAC system either continues to run, or where you have a smoky back system that the fans kick on, then you have a dynamic damper because the damper has to close under the velocity and static pressures of that system. As you can see, the pictures over on the right-hand side, static dampers, vertical, don't have any springs on them. And they're just gravity fed, so air is blowing through them. They close really easily, without any problem. But if it's under a dynamic type testing, there is extra springs added to the blades to pull the blades into the closed position so it closes under the proper flow. Now on the dynamic testing, you have everyone test to a minimum of 2,000 feet per minute at 4 inches of water gauge. That is the minimum base UL testing. With that is they have extended ratings in the UL procedure. You can test at 1,000 feet per minute increments above 2,000, so you can go to 3,000 or 4,000 feet. And the static pressure is at 2-inch increments. So it starts at 4 inches of water gauge and can be tested up to 6 or 8 inches. And with that, you can test any combination thereof. So we can test and get a rating at 2,000 feet per minute and 8 inches of static pressure, or vice versa, and do 4,000 feet per minute at 4 inches. So there's a lot of different testing that is done, and anything less, if you have a 4,000 feet per minute unit, you can use that in any system that is less than 4,000. So even if you have a 1,500 feet per minute system, you can still use the higher rated dampers. Next is the leakage testing, which all smoke dampers have to go through. There is class 1 leakage at 8 CFM per square foot at 4 inches. And you have class 2 is 20 CFM at 4 inches of water gauge. The International Building Codes call out minimum of class 2 for the United States. And for any attendees that are north of the border in Canada, Canada still uses class 3 fire smoke dampers, which is 40 CFM per square foot. And at the United States, we removed all that out of our building codes. The dampers are also tested and gives you an assembly rating, which is the temperature. It starts out as minimum of 250 degrees and can be tested up to 350. And then you have your dynamic rating, just like on your fire dampers, starting at a minimum of 2,000 at 4 inches. So with this testing, you can have a combination of different velocities, static pressures, and temperature ratings. The biggest burden that as you get higher temperatures, electric motors do not work as well under high temp. So it has a lower torque rating when you get higher temperatures. Then if you go at 350 degrees, also all dampers are made out of steel. Steel expands as it gets hot. So as it expands, the torque on the damper goes up. So this testing takes in consideration that the lowest torque of the motor and the highest torque of the damper with the airflow going through it will operate that unit under those listings. Next is the combination fire smoke dampers. This is kind of pretty simple, just like the UL testing, is you take the fire damper testing and the ratings, and you test it from that, and you test it for the smoke damper, the leakage, the assembly temp, and the dynamic closure rate. So you just combine the two tests, and then you have a combination fire smoke damper. And you still have the same ratings for using it for less than 3 hours. You use an 1.5-hour damper, and 3 hours or greater to use a 3-hour damper. And then you have the UL 555C testing. This is for ceiling radiation dampers. The ceiling radiation dampers have a rating of 1 to 4 hours. And the CFD assumes the rating of the ceiling assembly that is installed into. Currently, all ceiling radiation dampers are static rated only. So there's not a model out there that is available for dynamic use at this time. And the part 2 of
Hey Kent, if I can interrupt you real quick, I got another question. So someone brought up a question on the static and dynamic dampers. What types of facilities are most common for static dampers, and which types of facilities do you more commonly see dynamic dampers?
Well, under today's, when we're just talking like fire smoke dampers, is most of the time the engineers that are doing the HVAC system really don't know, or picking out the dampers, what type of fire alarm system is going in the building, and or what the operation sequence is under those conditions. So if you have a static, you can use a static system, but most people don't know that at the time because it's still being designed. And so most everyone uses a dynamic fire damper just to be safe, and it's not a bad idea to do that across the board. So I hope that answers the question. So next is installation. The installation instructions are shipped with every pallet of dampers. So on the job site, they should have the dampers ready to go. Right there, we put it in with the packing slip. So if it doesn't get thrown away, they should have it on the job site. If not, all of our installations are easily accessed at Ruskin.com under that model, and the installation is easy to pull up. Per the International Building Codes and NFPA 90A, installations of the dampers are to be per the manufacturer's installation instructions and per the UL listing. So all of our installation instructions that we have published actually go to UL for verification of how the damper was tested and all the ratings, and they approve it to allow us to use the UL marking on that installation instruction. So when you have it out there, you know it is a good installation. It is not something that's just been thrown together. So next part of installations is mounting angles. Mounting angles for the damper shall be a minimum of 1.5" by 1.5" by 20 gauge steel. That is just the minimum thickness and dimensions that every manufacturer has. That's the minimum angle size. Now we have our fast angle that we produce and ship with the damper. It's supplied, supposed to be wrapped around the damper, and it is a lot easier and lower cost than a shop-made angles. Then if you need angles both sides of the damper, we have our PFMA, which is the same angle, it's just you get 2 angles per damper instead of 1 like the fast angle. Next is opening sizes. This is a question that is to my attention all the time, what shall my opening size be with the damper? So the opening clearance is simply state is the opening for the damper that it's installed into needs to be larger than the damper first. That is so the damper is not squeezed in and get out of square. Excuse me. The minimum size of the opening, should be at least 1/4 inch larger than the damper. Then if you're using fast angles, and you can go all the way up to 1 inch larger than the damper. And there's optionals on this. They use 16 gauge angles as a fast angle, but you can make the opening up to 2 inches larger than the damper. So it gives you a lot of leeway on how large the opening can be for the damper to be installed. Next has to be framed. You've seen we showed you pictures of the duct impact testing. So the opening has to be framed so the angles can be attached on a fast angle on one side of the wall. So you have something to screw the sleeve to the angle, or the angle to the sleeve, and the angle to the wall frame to help to make sure that the angle stays in position during an impact testing. You have metal studs, details on all the installations, and you have wood stud framing. The difference is wood studs the opening has to be lined with drywall, so there's no flammable material right next to the sheet metal steel sleeve or damper. Metal studs don't have to be lined, but can be lined if the opening needs to be a little smaller or just extra protection. And it's not an issue to line opening. Now, when you put the damper in the opening, it does not have to be magically hovering with a 1/4 inch here, 1/4 inch here, just centered in the opening. The damper can fit in the opening. It can sit side by side, right next to the studs. It can sit on the bottom studs, as long as you have your opening clearance around the damper. Next, when you are the damper in the opening, please click it one more time, please. There we go. The requirement is that the center line of the closed blades are to be within the plane of that opening. So as long as the center line of the closed blades are within the paper thickness of the drywall material, you're within the plane of that assembly. So then the angles can be attached to the wall, like on angle one side and directly to the sleeve. All dampers have a label on them that says mount with arrow up. This is a mounting position, just like curtain dampers kind of shown here. The blades have to fall downward. And a combination fire smoke or smoke damper, as long as the blades are mounted horizontally, you can flip the damper upside down. Next is you have the mounting angle. Go ahead and click. The mounting angle must overlap the frame by 1 inch on all sides. This here is like using fire stop material. That angle covering that framing by 1 inch helps protect any flame from passing around the outside of the damper to the next compartment. So it is important that if you have an 1.5 inch angle, you ended up being too large, a little bit large on the opening, you can make your own angles and put them in, or you can purchase a 2.5 inch angle from us also. Now this is just a general picture of an installed damper. You have your expansion gap You have your mounting angles, you have your screw fasteners that go into the stud and into the damper sleeve, so where the blades can be within that area. And now you also have a maximum that the damper sleeve can extend beyond the wall. So in most cases, on a non-actuator side or access door side, the sleeve can only extend a maximum of 6 inches beyond the wall before the breakaway connection. On an access door or a actuator, then the sleeve can extend up to 16 inches beyond the wall. So it gives you a lot of play and different dimensions that you can work with. Now, as we were saying, angle one side, then now you got the gap on the back side. That is not required to be filled with any type of material, any like mineral wool or fire stopping. It has all been tested up to 90 by 48 or 48 by 90 without anything being packed into that opening. If someone wants to pack it with material, that will be up to the AHJ for approval. Next, you have a breakaway connection. So on sleeves that are 20 gauge, 22 gauge, down to up to about 16 gauge, you end up needing a breakaway connection. So that's where the 6 or 16 inch dimension comes in. And then the breakaway connections, so next slide, can be either duct mate or TDF or TDC or ward connections, any of the flange connections. With the flange connections, you can use metal cleats or plastic cleats. You can bolt the corner with metal bolts. And you can also use butyl or the neoprene gasket. So only requirement when you have flange connections is the number of cleats per the length of the side of the duct or the vertical part of the duct. So you can almost not put the flange connection on long in the field. Also, you have your standard SMACDA S and drive connections for UL breakaway connections that can be used. Now, note with these breakaway connections, there's only a certain amount, I think there's 3 or 4 different types of sealants that you can apply over the top of these connections. They are called out on our installation instructions in the note and gives you which materials are UL approved. There is a lot of good material out there, but some of them will actually, it's like using liquid nail or JB weld on that duct connection. It will not allow that breakaway connection to break apart. So you only can use the ones that are called out on the installation instruction for any sealants on your duct connections. Next is our round dampers. Round dampers are one of the easiest and least expensive to install. All of our round dampers are supplied with a factory cinch plate. The cinch plate is wrapped around the damper and tightens nice and tight against the unit. And only 4 screws are required to be mounted in the mounting plate directly to the studs. On the back side, on metal studs, don't require any other mounting plates at all. The opening also can be a nice square opening, so you don't have to cut the drywall out nice and neat around the unit. You can leave it open as shown in the picture here. Please note when you do have wood stud walls, you have to put the plate on the back side also. You have to have a plate on the front and back side. Round dampers also, only main requirement is the horizontal shaft on the blades is the damper can only be up to 30 degrees off horizontal plane. So it don't have to be perfectly level or perfectly horizontal. you can have 30 degrees that the damper can be rotated, so it gives you a lot of variance on how the dampers are installed. Next, we have a specialty installation. We did this, we take all the comments and questions we get every year, and we come up and say, how can we make your jobs easier? One main thing was dampers were a lot of times butted up against the ceiling or a wall to where the contractor could not install the angle on that last side. So we developed an angle 3-side installation. It allows you to use a fire stop material on that side that an angle cannot be installed. You put it on right around the damper, you slide it in, and put the angle on the other 3 sides. This is an intumescent material that is called out, and during a fire event, yes, the material does expand, but will expand across the top of the damper since there is nothing holding that material in place. So this makes a lot of jobs a lot easier to install when you're up against a ceiling or a wall, or even to be the floor. Another specialty installation we have is out of wall or out of floor dampers. These dampers are supplied with a 1/4-inch thick ceramic fiber insulation wrapped around the sleeve all the way up to the damper. This is so that the damper is UL tested, where the leading edge of the damper can be up to 8 inches out of the wall or out of the floor. Also with the out of wall dampers, for example, if you're using like a slot grill or a real small grill, and our minimum size on the damper is 8 inches and you want to use a 4-inch grill, this will allow you to do like a WC type of enclosure around the unit. The damper is mounted out of the plane of the wall, and only the duct portion that fits your grill can go into the wall. So it's great for, small grills or retrofit. If you're retrofitting a building and you just can't get the damper in the wall. So out of wall dampers can be purchased with a factory insulation wrapped around them. Next, we have our grill access and front access. We call these our shaft dampers because a lot of times the shafts just have a grills mounted right to them. The grill access, GA, is the actuator is mounted in between the grill and the damper blades. The front access, FAs, the actuators are mounted in a cabinet on the side of the unit. With the advantage that you have to having both assemblies is a grill access, you have to have a little bit deeper assembly to fit the actuator and electrical components on fire smoke dampers. On front access, since the motor is mounted in the cabinet, you actually have more room to mount it, and then the sleeve assembly can be shortened up. We can build a front access damper to 12 inches wide by 8 inches tall with a sleeve length of 10 inches deep. That's the shortest in the industry for your assembly. And as you can see at the back pictures on the right hand side are pictures of a 12 by 8 FSD. For the shaft dampers, we have framing detail. These are UL installations that says yes for your shaft walls, where you can use CH studs, CT studs, the J runners, etc., and how to notch them and put them together to form the framing opening for your fire dampers or fire smoke dampers. So this is a nice, easy installation, and it can be matched and can be followed by any contractor building the walls.
Hey, Ken, we have a question. Pretty easy. Where can I find information on installation types and procedures?
All the installation types and procedures are at Ruskin.com and is located under each and every model on the damper under the installation instructions. Also, there's another tab on our website that says supplemental installations for all the specialty types of installations that we have available for you also. To elaborate on the installation instructions is we have a lot of YouTube videos. Just all you got to do is Google Ruskin YouTube channel, and we have installation instructions right there that you can pull up on your phone right at the damper and watch how the proper installation of that damper is to be. So you don't even have to look at our website on most of these anymore. Just go to Ruskin YouTube and be able to open up and watch the video. I try to keep all videos within 2 minutes or so it's not too long and you get boring to watch. So next is our question and answer sessions. So thanks for the questions that come in so far, but I can answer any other questions coming up, or does anyone has?
Yep, thanks, Kent. So like Kent said, our Q&A session is now open. Please use the box on the upper right side of your screen to submit any questions you may have, as some of you have already done. We will respond to all questions we don't get to in an email following the conclusion of this webinar. If you have any further questions after the meeting concludes, please feel free to contact Emma Barnhart. So it looks like our first question is, if a project spec says fire damper is required for 4-hour fire rated partition, does a 3-hour rated damper can be proposed? So can a 3-hour rated damper be proposed instead of a 4-hour?
Yes, there's not a UL listing for a 4-hour damper. It's only an hour and a half or a 3-hour UL listing. So per the International Building Codes and NFPA 90A, it states that anything less than 3 hours to use an hour and a half damper, and anything that is 3 hours or greater to use a 3-hour damper.
All right, thanks, Kent. So our next question is, what is the exact purpose of having access door in a fire damper and fire smoke damper?
One is that every life safety damper must have an access door. This is a requirement mainly to be able to verify that the damper is open, and you have to access the dampers every 4 years in general purpose buildings and every 6 years in hospitals. A damper test, a visual inspection on fire dampers is required. You have to be able to look in and see that the damper is open, and when you pull the link, the damper closes, and then you have to be able to reset it. So you have to have access to the dampers.
Right. All right, makes sense. Thanks. Our next question is, what is the difference between the smoke damper and the control closure fire damper?
Well, a fire damper and a smoke damper are basically constructed exactly the same. The testing is the same, except a fire damper goes through a fire test. It's the idea that a fire smoke damper, we utilize what we call an EFL, electronic fuse link. As it heats up, it disconnects the power to the actuator and allow the actuator to drive the damper closed in a slower manner, but pretty fast, usually less than 15 seconds. A smoke damper does the exact same thing, but the power turning on and off can come from a smoke detector or a fire alarm panel or something to turn it on and off. But they do operate exactly the same.
Right. All right, thanks. Our next question is, can we replace an actuator on site without losing UL 555S certification?
Now, per NFPA, it states that if there's a problem with the damper, repairs to be done immediately. Now, what's saying that is if you have a damper and the actuator goes out, as long as you supply the actuator of the exact same model and brand, then it maintains its listing after it's installed and verified everything works. Now, if you have an actuator that is no longer available, then you must consult the manufacturer of the damper for their requirements to upgrade and change anything on that damper.
Right. All right. So I think we have time for one more question, and it's going to be, are the fire damper and fire smoke dampers allowed to have paint coating or epoxy for complete assembly?
Now, it comes down to the damper blades themselves cannot be painted. That is paint. Most paint will burn and cause flame. So, and also if you paint blades and stuff and you close them, they may stick together and not be able to reopen. So we do have in our UL procedure that the outside sleeve of a damper may be painted for the mainly use to say, hey, it's red paint and it's a fire damper. So just the outside of the sleeve can be painted.
Right. All right. Thanks, Kent. And thank you for everyone for submitting questions. So that's all the time we have for questions, and we thank you for attending today's webinar. We will be sending out an email after the meeting concludes with responses to questions, certificates of attendance, and a link to next week's webinar registration. That being said, please join us next week on October 7th at 1 p.m. Central Time for our Part 2 discussion on life safety dampers. Thank you again for attending, and we hope you all have a wonderful day.